Good day, everyone, and happy World Space Week. And welcome to this special World Space Week event, which is being hosted by the World Space Week Association in partnership with the Moon Village Association. My name is Alma Palife, and I'm the Executive Director, World Space Week Association. Each October, from the 4th to the 10th of October, World Space Week unites the world in celebration of space and its impact on our daily lives. So this year, we're taking the conversation one step further by quite literally trying to imagine what it would mean to live on the moon. Today's conversation is going to bring together visionary experts from across the space sector. These are leaders who are helping to shape that future. So together, we'll be exploring the technologies, the partnerships, philosophies that will make lunar living not just possible, but purposeful. So at this juncture, I'd like to state that unfortunately, our colleagues from NASA are unable to join the conversation today due to the shutdown in the US. However, we do hope to have very fruitful discussions notwithstanding. So once again, happy World Space Week, and I'd like to hand over to the President, Moon Village Association, Giuseppe Ribaldi, for a few words from the Moon Village Association.
Good afternoon, good morning, and good evening to everyone around the world. So, first of all, thank you and happy new, basically World Space Week, as well as new happy International Moon Day, because the main reason why we have been able to join together with World Space Week is because this is also an event of the International Moon Day, and later on you will hear from the chair of the International Moon Day some word about it. The Moon Village Association is an NGO which was created about 10 years ago. We are a permanent observer at United Nations and is the only organization which brings together multi-stakeholder, that is space agency, government, industrial, as well as public. And so today is one of the examples. And the MVA is dealing with many activity going from lunar governance to economics, to cultural, to education and outreach. You're mostly welcome to look in our website. So since we have a very rich program, I would like then to pass the floor to the chair of the International Moon Day, which together with the World Space Week Association organize this lovely event. So thank you.
So we'll be having a video recording from the chair, International Moon Day.
Greetings to all, and welcome to this year's Joint World Space Week Association and the International Moon Day global event. The IMD was established in December of 2021 by the United Nations General Assembly as a declaration for man to celebrate a return to the moon. And in the spirit of cooperation between all stakeholders, we have had 4 very successful events throughout the world in the past 4 years. And this year we celebrated our 4th celebration, International Moon Day main event in Dubai at the University of Dubai in the United Arab Emirates. So welcome everybody, and I hope you enjoy it. Thank you.
So now that the welcome formalities are done with, we would like to start our conversation today, which we're kicking off with some keynote addresses that are centered on laying the foundations for lunar living. So we'll start off with John Mankins, who's the CEO of Mankins Space Technology. Thank you, John.
Good morning from California, and good evening and good afternoon to participants around the world. It is a pleasure to have this opportunity to speak at this first joint International Moon Day and World Space Week organized event. And I look forward to future events as well. I thought for my keynote that I would step back a little and pose a challenge, a question, a puzzle. When will humanity have true space settlement? And I've organized my talk around three major themes, beginning in the upper right. What you see is an image of a factory floor with robotic systems doing assembly and construction. Now, this factory floor, this image is, of course, here on the Earth, but the only way we will ever have true space settlement and we will ever have settlement on the moon, Earth's moon, is by establishing industry. We have to be able to extract materials. We have to be able to process them. We have to be able to use them to manufacture materials, consumables, products, objects that are of value in a society. So this includes, of course, oxygen. It includes chairs, habitats, tanks, pipes, pumps, vehicles, roads, all manner of things. Oh, and of course, robots and electronics and sensors, all manner of things that we take for granted here on the Earth that make an industrial society feasible. And all of this will need to be done on the moon or elsewhere in the solar system at costs that are not only not exorbitant, but which are competitive with the costs of importing those same materials, consumables, objects, systems from the Earth. So if we are to move to settlement, it means that we are not living out of a camper shell, out of a trailer, out of a minivan. We are living locally, and that means a local economy. And this is especially necessary if the moon and other places in the solar system are to become part of a larger solar system economy, and in the nearer term, a cislunar space economy. And only in that way will space activities be sustainable in economic terms. I turn now to my upper left image, which is a picture of a rather delicious looking, I have not yet had breakfast this morning, a rather delicious looking smoked turkey sandwich. And I put this here because it's a trivial object. It's not a crepe Suzette. It's not an elaborate French meal or an elaborate I'll say Japanese dinner, which can be very, very comprehensive. It's just a sandwich. And yet in these pieces of this sandwich, the bread, the lettuce, the tomatoes, the chicken or turkey, the spread like mayonnaise that's on the sandwich, there are embedded a host of assumptions. We have to be able to bake the bread. We have to be able to grow the wheat. We have to be able to make the flour. We have to have yeast. We have to have the farms to grow the lettuce. We have to be able to grow the tomatoes. We have to have soils. We have to have nutrients. We have to be able to raise protein objects. I say it that way, organisms, either fish or chicken or turkeys or what other they may be, what other species they may be, because we are not yet at the point of being able to walk up to a console and say, tea, Earl Grey, hot. Although I am in fact having a cup of Earl Grey tea this morning as I give my remarks. The spread, if the spread is mayonnaise, you have to have oil, you have to have eggs. All of these things and more depend on the creation of an ecology, a local ecology with, as I said, soil, with nutrients, with illumination, with all the things that allow you to raise the foodstuffs that humanity depends upon. And so this is another step in trying to have a true space settlement, without which there is not a settlement that involves humans. So we need industry, we need manufacturing, we need resource extraction for commercialization, but we also need food, we need an ecosystem, we need ecology for a biosphere, for a biological system. And all of this leads to the center image, that of a young child, in this case, in a spacesuit. And that is to suggest that we only have true space settlement when human beings can reproduce and grow and thrive physically, emotionally, educationally, societally in space, in a space habitat, in a space environment, as part of a larger humanity. And so I pose to the group and to our future thinking that these are key, not the only ones, but these are key components of a true space settlement. Now, behind them, there are innumerable other factors. That we need tremendous amounts of energy. We will need communications. We will need new systems of governance, on and on and on. But I just wanted to leave you with as this keynote, with this vision, this image of what it will take in order to realize space settlement. I hope sooner rather than later, and both farther as well as nearer. So thank you so much for your kind attention, and I look forward with great anticipation to the remainder of this meeting this morning. Thank you.
Thank you, John. And before I move on to the next keynote speaker, I just wanted to direct the audience to the chat box where we'll be running a poll. So we'd be interested to see your answers to some of the questions we'll be posing during the course of this discussion. So next we'll have Dr. Wang Zhongmin. He's the Director of International Cooperation Center, Deep Space Exploration Lab in China. Thank you.
Thank you, everyone. Good morning, good afternoon, and good evening. So it's a very great pleasure to have an opportunity for this webinar. So it's to celebrate International Moon Day and also the International Space Week. So by the invitation by Mr. Giuseppe, so it's I would like to share. Because the topic of today is living on the moon. This how is living, how is in the future. But I would like to share some of the practice of the China aerospace, because it's currently is in the world. So it's China, American, Europe, and other countries. Everybody just do a lot of the activities on the moon and also on the other planet for the deep space exploration. So this is a good experience, and it's a very good the practice for everybody to learn that how to living in the space in the future. Okay, so this is the presentation we call this the China's deep space exploration summer missions. and also is how to cooperate with the partners in the world. I come from the Deep Space Exploration Laboratory, which is the key national laboratory in China, responsible for the China Deep Space Exploration missions. We are the leading institution in the world for the deep space. So we're responsible for Chinese, the lunar exploration mission, the planetary mission, the solar system exploration, and other of the universe exploration. So this we are currently have some focusing few of missions with the Chang'e series mission for the lunar exploration, and also is a planetary exploration for the Mars, for the Jupiter, and for the asteroid. It's called Tianwen missions, and also is some ability service to develop the new generation, the super heavy launcher, and also is the cislunar, the PNT system, what is already have the two of the lunar the data relay satellite to have the in orbit. It's called Queqiao 1 and 2. Okay, this is a few of the missions we have in the past of 20 years. From the Chang'e 1, which is starting from 2007, and to the last year, then to this year, we have just in the middle of this year, we have launched the Tianwen 2, which is the Chinese first, the asteroid, the sample return mission, what is have launched in the May of this year, and plan to fly to asteroid at to sun next year, end of next year, and hope to have the sample and return back to end of 2027. And this is the first mission. It's called Chang'e 1, which is have launched in 2007. The purpose, the function of this satellite is starting of this Chinese deep space exploration mission, and the function is to have the full moon, the mapping, and also the 3D, the lunar image. And next one is after 3 years, we have launched the second for the lunar orbiter, and that not only to have higher resolution the image of the moon, but also have fly further to the Sun Earth L2 point, and also have a flyby another asteroid. It's called the Artemis. So it's this is a second mission, and the third mission is a soft landing on the near side of the moon, and after 5 years, so it's the fourth mission have the soft land on the far side of the moon. This is the first the being the lunar soft landing on the far side in the history, and also will. Sorry, there's some voice. It's after next 2 years, we have the Mars mission, have soft landing on the Mars, and the same year as the Chang'e 5, we have the not only the soft landing on the near side of the moon, but also take the samples return back to the Earth. And it's from this time, because it's after 1970s is about the 60s years. It has no the human spacecraft taken the lunar samples back. So it's also very important to take some sample study from different places. And from the result of this mission, they have discovered some of a new material, new lunar mineral. It's called the Chang'e stone. And after that, there's 4 years. So it's not last year. we have the thanks by the lunar data relay satellite, we have successfully made the first time of the sample return back from the far side of the moon. So this is the first time in the history. And another 2 kilo of the lunar sample have returned back, and we have bring last year in Milano, and this year, just last week in Sydney, we have a bring of the piece of the sample rock from the far side, both of the far side and the near side, for the moon to Sydney, have to show, and also currently the near side some samples have opened for the global scientists for the applying. So whoever scientists could be applied for this the lunar samples and to have the research, and a lot of the scientific result is already discovered. So this is a field of the lunar mission. And just to say in the beginning, in the middle of this year, we have successfully launched another the asteroid, the explorer mission. Is called the Tianwen-2. This is going to fly to one of the asteroid. It's called 2016 HO3, which is 45 million kilometers away from the Earth, and would like to fly by and take some of the samples from the asteroid and return back. One part of the return back to the Earth, and another part will further flying to reach another comet. It's called the 311P. Yeah. So this is a quite complex mission. Will be lasting about 10 years. So some of the mission will be implemented next year and even the year after. So the first lunar mission is about the Chang'e 7, which will be launched in the middle of the next year. This is quite important because in the past 5 missions, we have the quite good the technology verification. We have to take the sample and return back. And this time we will go to the south part of the moon and to see that what if there's a real have the ice water exist in the South Pole, because it's a lot of the probe have the flyby from the orbit to detect that there's hints that there will be the South Pole have the water, but no direct evidence where is it located, how restored, and how much of them there's ice water is that possible to use. So this is a quite important mission for the Chang'e 7 to have direct detected and to make the direct evidence for the existence of the ice water. And 2 years after, we'll have the Chang'e 8. Because the topic of this webinar is called living on the moon. So we have prepared to establish a permanent infrastructure. It means to have the lunar base. So if want to live in there, this should have some facilities to bring the basic facilities like the telecommunication tower, like the solar panel station to provide the power supply, and also the local communication network to establish. So this is the Chang'e 8. So this is a few of the scientific object of the Chang'e 7. There will be a detection and reach of the ice water, and the components. What is the volatile components in the lunar soil, and also to detect and research the lunar inner structure and magnetic field and also the thermal characteristics. And also is have the comprehensive exploration and research of the lunar South Pole surface environment and to make the preparation for the next mission of the Chang'e 8 and even the future International Lunar Station, which is will have built the permanent infrastructure on the South Pole. So this is the few parts of the Chang'e 7. Similar to the Chang'e 5 and 6, we have some orbiter and lander, but this time and rover. But this time we have the new of the hopper. The hopper is different. What is like the ascender, which is using the sample return, which is in the last mission. The hopper will be fly twice into the inner deep of the cracks and to find possible to have the ice water inside. So this is Chang'e 7. Beside of the lunar missions, we also are thinking that in the as the lunar living as is the beginning, but in the future we will also have possible the living in the other planet like the Mars, and also we should have some of defense for the near Earth asteroid. So this the demonstration mission will be taken possibly in 2027. So we'll have some to select one of the near Earth asteroid. We have some to send off two of the probe. One is flying by to watch, and another one have a kinetic impact to the asteroid to let this asteroid to change its the orbit. Yeah. So the next the planetary exploration mission is called Tianwen-3. It will be launched in 2028. This is first time for the Mars sample return because it's NASA had made some of the missions. It's already have some samples on the Mars, but they have not yet decide when to bring those samples from the Mars to the Earth. But this time we will plan to have directly to send of the spacecraft, not only on the orbit of the Mars, but also we'll have soft landing, similar to the lunar mission. We'll have soft landing, have sample return, have sample collection, and also return back to send this back to the Earth. So that's hopefully will be reached to the Earth in 2031. So that will be if this successfully, that will be the first time the human to get the Mars sample from the Earth. Yeah. So there will be I think it will be very good starting for living for next time. We'll study to how to living on the surface of the Mars. Yeah. Okay, by the human, yeah, because it's quite important. Not only the robot, the living on the moon, but also very important is how is the human living on the moon. In the before is only United States have sent its astronaut the Apollo mission. So it's 7 Apollo mission have sent astronauts on the surface of the moon, but it's just short stay and return back. In the future, if we should have some the lunar base, lunar structure, and also will be habitat, will be allowed the astronauts have long-term to stay on the surface of the moon. We should have them firstly to reach there. Therefore, China have prepared to send the astronaut firstly to the moon by 2030. There will be 2 or 3 of astronauts. Of course, firstly, still in the equator, And the future will be see that it was what is the best place for the lunar base on the equator or on the South Pole. Because the South Pole will have some ice water, could be have some long-term the solar power supply, but also the equator is also have the good advantage that will be more directly can just go and back to the Earth. So it's we'll to see that what is the best place, the location for the permanent for the lunar infrastructure. Okay, in the future is also we'll see to explore.
Wang,
Yeah.
Due to time
Yes.
constraints, can I ask you to try and wrap it up due to time
Okay.
constraints?
Okay. Sorry. Okay. So this is a future of planetary exploration for the Jupiter, and also this is quite important. Currently, we have cooperate with global countries to go to establish the infrastructure of the International Lunar Research Station, and we already have the lot of cooperation with European countries, then the developing countries. So in the next year's mission is also several of the countries to participate, and the goal is the 50 countries to work together, 500 institutions, and currently we already have about 20 countries to participate and 70 of the global institutions as partner. And we also have a create a new organization. It's called the International Deep Space Exploration Association, and currently have 400 members, and including several important members like the COSPA and also MV and other agencies. So this is the goal of this association, and we would like to establish such a cooperation network to working. Everybody can work together to learn how to living on the moon. Thank you very much. Sorry for the long-term delay. Yeah, sorry.
Thank you, Dr. Wang. We appreciate that you had a lot to say. So we're going to move on very swiftly to our spotlight talk from Lockheed Martin, which is a company that supports both World Space Week and the International Moon Day and Moon Village Association. So I'm going to call on Tim Sheehan, who is going to give us a talk on building habitats beyond Earth, designing for survival and sustainability on the moon. Thank you, Tim.
Thank you. And welcome, everyone. I'm excited to speak here today. Lockheed Martin is a proud industry partner for the Artemis program. We are super excited that we'll be flying crew early next year, as early as February, on the Orion spacecraft to fly by the moon. That'll be the first people to go to the moon and fly by since 1972. And the way the trajectory works, they will also break the record for the people who go the furthest from the Earth. Lockheed Martin also has a long history of doing science spacecraft, whether it's OSIRIS-REx, bringing an asteroid sample back from Bennu, or the Grail mission, which mapped the moon's gravity in high detail. And we're really excited to see the Artemis Accords growing now at 56 nations. But today I'm going to talk about our vision for habitation on the moon. And we're not quite focused at Lockheed Martin on full settlements like John described, but we have worked concepts for what does the long-term vision of Artemis Base Camp look like, and our concept there is in the picture on the bottom. And then in particular for habitation. And so from a safe perspective, couple of things that I want to highlight about the difficult environment of the moon and how we need to plan and design for that. When I think of safe, some of the things I am concerned about as a space architect are the radiation environment outside Earth's Van Allen belts, being exposed to both galactic cosmic rays continuously, as well as solar events and proton storms. Also, we need to be concerned with micrometeor impacts and impacts that might be caused by lunar landers and that activity. And then the other part is needing both reliability and redundancy for systems. At the International Space Station, you can be home on the ground in 90 minutes in some sort of emergency. From the moon, it's at least 3 or 4 days to come home. And then we're getting ready for Mars, when it could be 1,000 days to come home. So redundancy and reliability of systems, dissimilar redundancy, where you've got two different types of systems working together, those are all important. So the picture in the upper part of the slide shows shows a moon village of habitats, both metallic and inflatable structures. We've been working on soft goods as a material for habitats for a while now. Soft goods provide a number of advantages, including being able to expand in volume, but be packed smaller for launch. But there's other advantages as well. Particularly the multi-layer construction is very good for both radiation impact mitigation and micrometeor impacts. And some of the testing that we've done has shown safety factors as higher than 5 times the pressure that these habitats need to survive. The other part of the question is sustainable. As we stay for longer and longer periods on the surface of the moon, being sustainable is important. And we're focused from an in situ resource utilization, ISRU perspective, on water ISRU. So of course, for drinking water, for splitting the water into hydrogen and oxygen, to have the oxygen to breathe. But from a sustainability perspective, one of the great challenges is the transportation costs in propellant. It takes a lot of propellants to go from the Earth to the moon, and then more propellants to be able to land safely on the moon and then take off again. And so we're focused on building the technologies, both in the processing of water, in finding the water, but also in providing the high levels of power needed to produce hydrogen and oxygen propellant to enable the transportation back and forth to become more sustainable, and to rely on resources from the moon. So at this point, we're very excited to be starting crewed Artemis missions next year. We've got a set of Artemis missions to land on the moon coming forward. NASA and the other Artemis Accord nations are working towards building an Artemis base camp, and those will lay the foundation for a sustainable level of activity on the moon. Thank you.
Thank you, Tim. So, and thank you to all the previous speakers for really setting the scene for what's coming up next, which will be the panel on building habitats, on living on the moon, challenges, opportunities, and global cooperation. So we're going to have that moderated by Satoru-san Kusoro from the Moon Village Association. So I'll hand it over to you. Thank you.
Okay, good morning, good afternoon, and good evening from Japan. Let me share my screen. Can you see my slide? Okay, good. Okay, let me start the panel discussion, Living on the Moon, Challenges, Opportunities, and Global Cooperation. I'm honored to moderate today's panel with distinguished guests. My name is Satoru Cross. I'm a board member of Moon Village Association. So here I'd like to invite you, the panelists from different background, different expertise. We have a very diversified, distinguished panelists. And first two panelists already gave the presentations, like Dr. Wang Zhongmin and also Mr. Timothy Chihan. Also, I'd like to welcome Bob Lamborey from Luxembourg Space Agency, and Ms. Upia Botazatsu of UN COPUOS. And lastly, Marianne Luzier from For Mankind. So I'm Satoru Cross. I'm a board member and also the Moon Market Development Coordinator. And I'm also the co-chair of an industry working group, which was established about a few months ago. As a business, I was a founder of the Business Development Office of Yokogawa Electric Corporation. Yokogawa is the automation company, has three main technologies, measurement and control and information. And for the moon, we recently got the order from Toyota to provide the sensor and also control computer for their lunar pressurized manned rover called the Lunar Cruiser. I'm also having my own company called Cross Space and Sustainability LLC. So let me introduce our panelists. Already the Wang-san and Timothy-san show up, but could you a little bit explain yourself for the people who may join later on? Okay, Wang-san, could you start your explanation about yourself?
Yeah, okay, thank you very much. Thank you for to listen to my presentation. That I'm the director of the International Cooperation Center of the Deep Space Exploration Laboratory of China. So it's in the presentation is already have introduced the DSEL is the China GPL, the focusing and responsible for the deep space mission in China, as a subsidiary of the space agency, the CSA, and I'm also the expert, the ILRS, the International Cooperation Group by the CSA to nominate, and a co-chair. I'm very glad to be the co-chair of the GIXLA, the third group of MVE, and also the member of the Space Exploration Committee of AF, and also is a IPC member of the GIXLA 2025. So I have the 30 years experience in the space industry for several of the global space corporations missions. For example, the China is the Galileo Corporation between the China and Europe, and also it's a lot of the satellite EOB delivery export to different countries. And I was also several of the director of the few of the company, like the German Eurospace GmbH, and also some of the other Chinese company. So thank you very much. Very glad to meeting with everybody.
Thank you very much, Wang-san. So next, Tim-san, could you introduce yourself?
Sure. So I'm the space exploration architect at Lockheed Martin, and that role involves looking at developing concepts, leading engineering teams to look at the future of everything we do in commercial and civil space. So whether that's human spaceflight or interplanetary science missions, weather and our science are all part of my role. And I started though on geosynchronous commercial communication satellites. My background is in trajectory design and mission analysis. And then I joined the Orion program in 2007 and spent about 10 years on Orion in a number of different roles, including launch abort system trajectories, instrumentation design, delegate spacecraft engineer, particularly for our first test in space, Exploration Flight Test 1, and then ending with being the system architect for Orion. And so I'm also a member of GEXLA. I'm the vice chair for industry and a co-chair of Working Group 2 on technical coordination. A member of the IAF Space Systems Committee, and a full member of the International Academy of Astronautics. And I also did want to share a little bit more about the work that we're doing. Here we go. Okay. So last year we released a short story novella white paper called "The Vision for Humanity's Future in Space," and it looks at our ideas around what the moon could look like in 2045, and the story follows along with a commercial astronaut working on and repairing infrastructure on the moon. So if you take a picture of that QR code, you can download the white paper, and it goes through all of the different systems that we will need to have sustainable activity on the moon, from power to mobility to habitation to even a short description of electromagnetic launch for all of those resources.
Right, thank you, Tim-san. So next, Bob-san, could you introduce yourself?
Yes, thank you, of course. Welcome, good day to everyone. Bob Lombre from the Luxembourg Space Agency. I'm a senior manager for exploration and space resources, and I'm also the Luxembourg delegate for the exploration program at the European Space Agency. Maybe as a few introductory words on the work we do at the Luxembourg Space Agency to explain a bit the background and also what we do and why we join here the panel. So the Luxembourg Space Agency is not a traditional space agency as the large agencies like the China, the NASA or JAXA in Japan. We are more our mandate is more to drive the economic development of the industry, and in the frame of that, we believe that space resources will play a major role in the future when we want to develop a future space industry, space economy, lunar economy, and so in general the resources hold a lot of value for the economy. And that's why we're in 2016, we launched an initiative that was called Space Resource.eu initiative. It's a very broad initiative led at many different levels in the government. And it's not a mission in itself, it's not a technology roadmap, but it's really a broad initiative to create an environment where we can we understand how to use and are able to use the resources in space, lunar resources, but also the initiative itself also addresses asteroids and Mars. So it's very generic, a very broad initiative. And in that initiative, when we started, we identified various challenges. It's very long-term vision, but it provides a nice guidance for the work we do. There's a technical challenge, there's the governance challenge, there's the business challenge, and the financial challenge. And we try a bit over time to address all of these different challenges in parallel and find answers. So, for example, we're very active on the regulatory side to provide to contribute in providing a clearer framework on how to use resources, what this means. So on one side, we have put forward our national law on space resource, but we're also very active at UN level to find a common understanding at international level of what this means actually using space resource. And it's very, I think on the moon is a very probably the first place where we see this, and if we want to do more than Apollo, at some point we need to learn how to use those resources. But beyond that, we also work with universities and to create the talents, the future engineers and scientists. we created a European Space Resource Innovation Center together with the European Space Agency to develop the technologies and the knowledge to be able to use those resources. And we also fund projects with industry and technology development in line with this long-term vision. Thank you.
Thank you very much. Alpia-san, could you
Yes,
start?
thank you very much. Thank you very much. Good afternoon, everyone. Ulpia Bottasato. I'm honored to represent the United Nations Committee on the Peaceful Uses of Outer Space, where I serve as the chair of the Scientific and Technical Subcommittee and also as the co-chair, together with Pakistan, of the Action Team on Lunar Activities Consultation, ATLAC. I'm also Space Policy Officer at the Romanian Space Agency, and I'm a national delegate to European Commission, to International Standardization Organization, and to ESA, European Space Agency, at the International Relations Committee, Security Committee, and Program Board in SSA. Finally, last but not least, I'm also an implementation support officer at GEXLA, and I'm very honored to be here with you today. I'm very grateful to our host for bringing together such a diverse panel. It's a privilege to join and to contribute, I hope, to this very important dialogue about the future of lunar exploration. Just to say a couple of words about myself. Throughout my career, I have worked really at the intersection of science, international policy, and technology, advocating for peaceful cooperation and sustainable practices in space. And really, I look forward to exploring with you how our collective efforts can make lunar living a reality while ensuring that the benefits of space exploration are shared equitably, and that our shared heritage is safeguarded for the generations to come. Thank you very much for having me here.
Thank you very much. So lastly, Marin-san, could you introduce yourself?
Hello, can you hear me okay? Yes? Yes, good. Okay,
Yes.
so my name is Dr. Marlene Luzier. I would like to first thank very much Satoru and Alma for the very generous invitation to join such esteemed colleagues. And it is a great pleasure to be able to speak on this subject, especially under the auspices of the Moon Village Association. So just in terms of my background, I'm a legal expert in international law, and my expertise is on the development of international law, where there seems to be less clear indications about what the law is and perhaps what it should be, including legal, ethical, and moral considerations. So my background before coming to For All Mankind as the head legal expert under Michelle Hanlon, who had established the organization a little less than 10 years ago and brought it to permanent observer status at the UN COPUOS. I was an attorney practicing international law, arbitration, also corporate matters for a large international law firm, worked with many sovereign states, and with a lot of questions that were very nebulous. But I left that to really pursue the law of culture. So my specialty is really entitled propriety rights over cultural properties under the water, particularly those that are beyond national jurisdiction or in conflicting jurisdictions, for example, in the cargo of sunken colonial vessels that is then found and potentially retrieved, and also in disputes over, again, title and propriety rights over cultural objects and sites, particularly objects that have moved internationally and within historical dimension, particularly that descendant from colonial regimes, and as well this more novel idea of the sites and cultural objects on the moon. So where I work, particularly in advising For All Mankind, is how to extend the legal regime under the UN treaty regime under the UNESCO conventions in culture to the moon. So we have conventions under UNESCO, which is the cultural branch for cultural objects that cannot move, cultural objects that are movable, expressions of culture and diversity. And then there was a combination of the United Nations Law of the Sea Convention and the UNESCO Cultural Conventions to develop the 2001 Underwater Convention. And so the hope is that there'll be a collaboration between UNESCO and not the Law of the Seas, auspices of the UN, but instead COPUOS. And so this is what our presence has been particularly emphasized around at COPUOS. But we are an organization of many volunteers all around the world, whether in science and scientific and technological or in the legal expertise. But in addition to that work, I am also the chair of the International Astronomical Federation Committee on the Cultural Utilization of Outer Space, as well as the vice chair of the Committee on Liaison between International Organizations and Developing Nations. And in that context, what my work really also aims to do is to help develop a legal regime, legal standing for a greater number of parties to participate in determining the identities, and the protections or safeguarding measures for sites and objects on the moon, as well as objects that are imported and exported from Earth. So this conversation is a quite exciting one. I hope it's one that, of course, we'll enjoy today, but that we'll have the opportunity to continue into the future. And in doing so, I'm happy to bring those conversations as well to the UN General Assembly, to the Security Council, to the ECOSOC, which I have done in the past. Other than that, yes, my practice is based in Washington, D.C. And like I said, I'm a legal expert and opine on these matters. But thank you again for the invitation.
Thank you very much. So what a panel. So excuse me, all the panelists from all over the world and all the experts from the different expertise. So I'm pleased to moderate this panel. Okay, so I have prepared some questions. Let me share my screen again. No. Okay. So first question, what are the challenges and opportunities for living on the moon? So quite a general question, but this is a good question for the start because you have different background and different insights. So can I ask Wang-san to answer to this question first?
Okay, thank you very much. So it's I think in the first presentation, it's already have several of the answer for this question that is especially for the challenge, because it's the lunar environment is totally different than what are the Earth. So it has all have to have less gravity and the no atmosphere. So it's and the temperature difference is very large at day night and lunar day and the lunar night. So there will be highly radiation. So it's because they have no protection of the atmosphere, and so it's the real high radiation. So it's for the human being is difficult to live in there. Even for some of a robot, the electronics is also have some of very easily to damage. So this is quite a high challenge, and also the poor role for the resources, because it's this is set as has the ice water, but it's only on the polar region. So it's difficult to explore and to use it. And also it is very difficult to make the infrastructure. So the best way is to find the lava tube, and also they need to build a shelter. So we cannot bring the lot of materials from the Earth to the moon because it's so costly, very expensive. So we have to use only the the lunar soil to make the break and make the construction. But this is very long term, and its efficiency is very low. So this is a lot of the challenge. So therefore, currently we are just in the beginning to study about it. For the long-term living, this is still a long time we need to learn. So this is quite very high challenge. But the moon is also, there's a lot of the resources could be in the future to use, especially like the helium-3 everybody have talking about. So there will be the set is ultimate the resources for the human the power. So if we can get this the helium-3 bring that into Earth, that will be nobody will be worried about the electricity power problem, and also will have some of new technologies to use. What if we can just make this lunar living successful? Those technologies already will be developed to benefit for the people. So therefore, I think it's a lot of the very high challenge, but also is quite a good opportunity to live to people living to learn how to living on the moon. Yeah, thank you.
Yeah, thank you very much. So the Chinese mission is especially looking for the helium-3 as a potential resources. So, but you talk about nobody should forget about the resource problem on the Earth. So this means that you think the helium-3 is big enough to sustain the the energy consumption on Earth. Is there any?
Yes, yeah, because this I'm located in China, so it's the headquarters is in the central city. It's called Hefei. In Hefei is also the central city in China for the nuclear fusion.
Okay.
So it's a lot of success is already made for the nuclear fusion by the huge of tokamak, the fusion equipment. So if they could be make success, the helium-3 is the best material to use to generate the power. That will be to supply all over the planet for 50 or 100 years. So nobody will worry about the issue of the power supply.
Thank you very much.
Thank
Okay.
you.
Tim-san, same question. So what are the challenges, opportunities for living on the moon?
Thanks, Tori-san. So from a challenge perspective, I think the lack of infrastructure today is one of the challenges as we start doing operations on the moon. So, there's no GPS, there's no cell phone coverage, there's no high-speed links back to the Earth yet. And so we need to be able to build up that infrastructure while not being supported by infrastructure. So things like building local communication networks on the surface for the base, local navigation beacons as you move about on the surface as well as you're coming in for landing. And then also the connections back to Earth, relay satellites, maybe even optical communication, laser communication back to Earth, because we will need to have the internet on the moon, just as we have the internet on the International Space Station. It'll probably not be as fast, but those things need to be built up. And I think another aspect of infrastructure is things like landing pads and roads and protective berms built out of the regolith to keep the dust down and to keep the impacts of regolith being shot out by landing vehicles. So that's pretty important. From an opportunity perspective, I very much agree on the resource side, both for water, but also silicon and aluminum being able to be made by regolith. I imagine a future where there's a factory on the moon, there's factories in Earth, all being supported by those resources. But I'm also excited about the scientific potential for the moon. There's no plate tectonics, there's no atmosphere. The moon is, in particular, a great record of the time in the solar system when asteroid bombardment was happening, life was starting on Earth, and the moon is a record of what that solar system was like. So very exciting. And also, we talk about the far side is in some ways, the only place in the universe that is fully blocked from radio emissions from Earth. And so radio telescopes on the far side are also a very intriguing opportunity at the moon.
Yeah, thank you very much. Next, Bob-san, and I'd like to ask you as many questions as possible. Could you respond target within 1 minute, please?
Okay, I try to keep it short. I think a lot has been said, and there are definitely technical challenges. And in the short term, I think this means learn more about the moon and also build up the infrastructure to be able to operate. But I think when the biggest challenge is the business case, if you want to say so, for the moon. I think if you want to say live on the moon, we must have a reason to be there, to stay there, to make this sustainable in the long term. And I think the challenge what we see is to find in the next years the business case for the moon. Maybe it's the helium-3, maybe it's something else, maybe it's probably it will be a mix of many different activities. It will not be one. But the challenge we see is really to make this, if we want this new lunar exploration, make it different from Apollo and live there or stay there in the long term, I think it's really about finding the reason to stay there and to stay operating there. And the opportunity, if we succeed, we definitely we'll be able to extend this economic sphere from Earth to the moon, and this will open up then lots of opportunities in the long term.
Well,
Thank you. That's more or less 1 minute.
Yes. For your cooperation. はい。ルピアさん、from UN point of view, maybe?
Yes, I think it's a lot of pressure on me now. Many points have been said already,
Yeah.
and I will just try to mention them with regards to our activities at the UN. So on the environmental extremes, the moon's low gravity, lack of atmosphere, extreme temperature swings pose risk to human health and equipment, and we have the UN COPUOS long-term sustainability guidelines that call for operational safety, environmental protection. And within this framework, ATLAC is mandated to develop recommendations that avoid harmful interference and ensure safe operations, helping to coordinate international standards for radiation shielding, dust mitigation, and thermal management. This is just to put it a little bit in the context. Another challenge and opportunity is the infrastructure and habitats, as has been pointed out already. That must shield inhabitants from radiation, and concepts, of course, include lava tube bases and 3D printed regolith structures. And as a link with ATLAC, the ATLAC's consultation mechanism aimed to facilitate information sharing on programs, methods, and tools for all phases of lunar missions. We are trying to foster this open exchange between member states, but within each member state delegation to have represented the view of agencies, private entities. The scope was in a way or another can encourage compatible habitat designs and shared safety standards. On life support, the UN COPUOS framework promotes international cooperation and scientific research again, and ATLAC serves as a platform for states and observers, hopefully in the future, to exchange best practices on life support technologies and to identify capacity building needs. And this aligns with the recommended topic of sharing information under any future consultation mechanism. And last but not least, resource utilization, waterized metals, helium-3 could support local industry and reduce costs. And resource use has legal and operational implications. COPUOS Working Group on Legal Aspects on Space Resource Activities coordinates legal principles. And of course, in ATLAC, we are also attempting to discuss or to focus on consultation modalities, including notice of activities, and again, avoidance of harmful interference. Thank you.
Very much. Maran-san, did you give the word?
Yeah, sure. Thank you. So I will just touch base a bit about the ethical and legal considerations for lunar settlement. That correct, Satoru? So as we know, there are many issues that come into play, but I think looking at this question more in the broader sense, in terms of what the ethical and legal issues are and how we would identify and move to build a more ethical and legal system. The question is whether we've been able to do that here on Earth. And considering the geopolitical and legal issues, the now increasingly important relevance of ethical issues that have entered the conversation, I think this discourse on what to do for lunar settlements is a big question. However, I'll just go through some of the main issues, particularly this idea of first come, first served. So there are many states or entities that are able or soon will be able to access the lunar surface and perhaps begin with settlements. But then what happens to those that are not first in that trajectory? So the idea is that, of course, we would allow for the opportunity for all humans to be able to do like things on the moon. But considering our history, the question is whether that will happen. Then, of course, we have the non-appropriation principle of the moon, the space law treaty under the UN, and that is also an issue that we're working on. For example, at COPUOS, what would that mean, and would we be able to stick to those notions? Although the Moon Treaty is now a treaty that has been very broadly ratified, it still necessarily is a UN treaty, and the possibility of looking at those principles or broadening those principles also calls into question ethical and legal issues. Then the idea of legal adherence, and of course the rules, enforcement. So then we get into ethical issues. And I think maybe one of the greater questions is, although there's much discussion, I think the main discussion is how the settlements would come to play, what rules would be established, how people would operate amongst themselves, what the sovereign jurisdictional principles be, but also the question of should we even be on the moon? So there are many communities around the world that perhaps do not feel that humans should be on the moon. So also understanding those perspectives and being able to bring that into the dialogue and being able to incorporate these different notions from different communities around the world and to really understand what the economic, cultural, geopolitical rights of individuals and communities would be. But I think the main question is representation. So hopefully we will do a better job at that at the COPUOS where these discussions happen. Thank you.
Yeah, thank you very much. So first question was quite generic, but also quite deep, and we need hours to discuss by this kind of expert. So let me ask the second question a little bit more, let's say, light. and ask a question to the Wanna private company and also the Wanna Space Agency. Second question is what will daily life on the moon look like? What will daily life on the moon look like? So ask to the Tim-san and also Bob-san to respond within 1 minute each. Tim-san, please.
Thanks. So I think that the life on the moon will be in some ways similar to what we see on ISS, where we have the aspects of daily life, where food and water will at first come from Earth, but we will be moving more and more towards a closed loop system where we are growing plants on the moon. We are recycling our water at a higher and higher frequency. And I think the growing of plants has been shown to not only provide nutrition benefits, but also mental health benefits for longer stays. I think the other unique thing about living on the moon is going to be the low gravity field. Gravity is going to make a big difference in day-to-day life compared to life on ISS today. It will make a number of things easier, and will have mitigations to the health issues that we see in zero gravity. But also, I think we don't know how living in a light gravity field will be. There will be a lot of science and research. The crews will be performing experiments in their own lab there on the surface of the moon to understand their reactions to that environment. And they'll be going, outside on spacewalks to perform science. So it'll be quite busy. It'll be quite intense. We'll be learning something new every day.
Thank you. Bob-san, please.
Yes, maybe to complement a bit what Tim said, so I agree that on one side, a bit like on ISS, we will be busy a bit to maintain whatever station or to survive, basically. I think to keep it operational. So I guess in the first phase, a lot of energy and time will be spent on that. And then on the other side, we have definitely science to learn, study the moon. And beyond that, maybe I'm a bit biased, but I think it's also we'll need to learn how to use the resource, how to exploit the resources or use them to make it more sustainable, to produce propellant, to build shelter, maybe to access the helium-3. I think these are all activities beyond pure science. I think these will be the activities at some point we need to perform to make this sustainable and easier to access.
Yeah, thank you very much. Okay, let me move to the next question. So before now we only have just about 10 minutes, and let me cover the one subject in this theme is the global collaboration. So what do you think are the global collaboration model? And I'd like to ask Wang-san and Rupiah-san. Wang-san from MBA member point of view, and also Rupiah-san for UN point of view. Wang-san, within 1 minute, please.
Okay. So regarding to the international collaboration, so it's a few of the great platform we are just prospected using for the lunar future corporations. So it's one is at the UN COPUOS level. So I think the Rubia will to introduce very detailed about this. It's, because she is the co-chair of the ADLEC, and also we have some of an initiative of 1 month for all. So it's initiated by the UN. And another one is this MVA is also great platform. So everybody is working on this. So it's a global experts. We are making the group, like the GEXLA and a few of the working groups. So I'm in charge. I'm the co-chair, and together to working together for the working group 3, which is for the multi-sector coordination. So we also have a lot of the work for that. For example, in the last year, we have proposed for the International Committee of the Lunar Operation ILRS, and this year we also have some of a proposal to making the practical framework for the effective the cooperation globally. So the next one is as I show in my presentation is the new for the international academic organization is International Deep Space Exploration Association. So this is also a great platform that we just created in the middle of this year, and starting from the Chinese and other for the European nations. So and currently is already have the 400 members from the 45 countries. So it's, we would like to also to like this organization to be the great platform for the coordination and the cooperation. Especially we will initiate some of international cooperation project like the Cislunar, the CubeSat constellation. So it's a few of the countries already interested and join this for this cooperation. We will initiate those very concrete the project to promote the collaboration for the future the lunar living. Yeah. So this is my view, and I think the Wobia will give more detailed about the UN COPUOS. Thank you.
Thank you very much. I'll try to be very short. 3 ideas. At the UN COPUOS, we are trying to cover policy, operational safety, international cooperation, and research. And one example that I already gave, but I'm giving it again because it's a good one, guidelines for the long-term sustainability of outer space activities. We have a lot of happenings within that working group. We also have other working groups which are of interest. In relation to that is ATLAC, of course, which was established by COPUOS in 2025, and it aims to propose a consultation mechanism by 2027, open to all UN member states, and focuses on sharing information, avoiding harmful interference, promoting capacity building, and it has hopefully an inclusive structure that somehow ensures that both spacefaring and emerging nations have a voice in shaping lunar governance. And the very last sentence, I would also like to address the GEXLA, Moon Village Association Global Expert Group on Sustainable Lunar Activities, that really complements the UN efforts by drafting detailed recommendation on what I've just said: information sharing, operational safety, environmental protection, interoperability. And because I'm implementation support officer, GEXLA is very dear to my heart, particularly because its unique structure of more than 60 experts from all around the world brought at the same table to discuss all aspects of lunar activities, be it scientifically driven, commercial, diplomatic, political. And I think collectively we really strive to offer solutions mainly for UN COPUOS delegations to have it as support in their decisional process. Thank you very much.
Thank you very much. Okay, time flies, and we are close to the end of the panel discussion. So could everybody, all the panelists, give a last word, including a message for the future generation within 20 seconds, please. Once again, please. Last words.
Okay, thank you very much. So I think it's because this we have only one moon, so this moon is for everybody, whatever you have nation or country. So this is we need the collaboration together for all of the people. Therefore, we should have to know that the moon is our future, the common future, common destiny for everybody. So this let's to work together.
Right, thank you. Tim-san.
I think a key theme here is sustainability. And I know we struggle here on Earth about that. But given the expenses, both in money and propellants and time, we won't be able to operate at all on the moon unless we do it sustainably. And so that forces us to do that. And I also want to highlight that the moon is one part of our journey. And we will always operate there and do science and do industry. But we're also looking towards the horizon goal of sending humans to Mars. And the moon is just an excellent place to practice for Mars and to use systems that we can use on the moon, we can use on Mars, whether that's habitats or nuclear fission power or ISRU. And so I'm very excited for the future, starting as early as February with humans back at the moon. Thank you.
Thank you very much. Nobu-san?
Yes, maybe I can just agree with Zhongmin and Tim. I think we have the opportunity to create something new altogether. This is far too complex or to do just by one entity or one organization. I think what's different here is that all the nations are currently involved in this lunar exploration program, and I think the opportunity is really to do this together. And there are many roles or so much things to do on the moon, so much things to learn, that I think it's we need to do this together and also in a sustainable way to stay there and be able to operate in the long term.
Thank you.
Thank you.
Luca-san?
I think living on the moon will challenge us technically, legally, ethically, but it also unlock tremendous opportunities for science, industry, and human inspiration. And we emphasize that inclusive consultation, shared norms are essential. And really, by working together, sharing data, aligning standards, protecting the lunar environment, we can ensure that our presence on the moon embodies peace, sustainability, and equitable benefits. Thank you.
Thank you very much. Lastly, Mara-san, please.
Yes. So I would just add one part, because I do agree with all that has been said by fellow panelists. I would say that with the modern technology we have on Earth, to be able to communicate through virtual calls, emails, airplanes, I think that this notion of really being able to learn from each other, not just present generations and future generations, but to be able to speak with each other about the contributions of our communities throughout time and throughout our cultures. If we are able to do that and really make the extraordinary effort to try to have those conversations throughout different generations, different cultures, then we would really be able to harness the capacity of humankind. And I think that will create better lives here on Earth, certainly be able to facilitate life on the moon and beyond. But that will be quite an incredible feat to really be inspired and to learn from each other and to harness our capacities.
Okay, thank you very much all the panelists, and also thank you very much for the attention of all the audience. And I'd like to close this panel session. Thank you very much.
Thank you to the panelists. And we did have some questions in the chat, but unfortunately we are running out of time for this program. So we'll probably send those questions over to you, Sotaro-san, and see if they can be answered in due course after the program. So for now, I'm going to hand over to the president of World Space Week Association to give some closing remarks.
Great. Thank you, Alma. It's wonderful to see this panel and to hear the panel. The panel is global, just like World Space Week itself. This year, we hope to exceed last year's numbers of 90 countries holding over 15,000 events. This week is a public forum on space, just like we're doing today at the global level. People are sharing their visions and thoughts about our future in space, living in space, all over the world this week. it's also a time to reach out to the public and to students. And the organizations that put on World Space Week include space agencies, aerospace companies, science museums, and of course, schools. And they do so for a reason, that by synchronizing into these 7 days, they all get leverage, because not only do they reach an audience that reverberates through media coverage, and so they reach many, many more people. So I'm excited about this week. I'm excited about this panel and everything that's going on around the world this week. So I want to thank our panelists, thank our audience on YouTube, and Giuseppe, thank you for the chance to co-host this with the Moon Village Association.
Thank you, Dennis. And finally, we'll have final remarks from Giuseppe.
Okay, can you hear me? Yes? Hello?
Yes, we can hear you.
Can
Yeah, we hear
me?
you. Yes, we
Yeah.
hear you.
Okay, all right, because I saw Alma. Okay, so first of all, I'd like to thank, of course, Dennis. We have been having signed an MOU some time ago, so this is a good opportunity to get together. And I think, IMD, International Moon Day, has been a good opportunity, and we hope that this is the first of many other opportunities to work together, because we have absolutely common goal, which is indeed to make the public and a number of organizations basically to talk about those issues, the moon and all space. And of course, again, so thank you to World Space Week. I'd like to thank specifically people involved in this endeavor, which is Elia, Glafki, Alma, of course, you, Dennis. And so I like again to thank everyone which has been following this and will organize World Space Week event for us in MVA, which is a younger organization. It is something to be imitated. World Space Week is difficult to be imitated because there are so many events around the world. We have just started with few tens, 50, 60. So, but we do hope that also with your assistance and wise advice, we can really expand, because the moon is the next goal of humanity. And so with that, I'd like to thank everyone, all the participants, and I wish you happy World Space Week and happy International Moon Day. Thank you.
Thank you, everyone. And if you do drop your contact details in the chat on YouTube, we'll be able to respond to some of the questions that we couldn't address during the panel. So once again, happy World Space Week, and thank you to all the participants and the panelists for this wonderful discussion.
Thank you.
Thank
you. Bye-bye.
Thank you.
Bye. Bye.
Thank you. Bye.
All right.